Hi everyone, welcome to our channel BA Civil Engineer. In this video, we will know about introduction to slopes. So, if you see slope, by name itself it says it is a inclined surface. Slope is nothing but a inclined surface. So, the slopes which are available on the ground surface can be classified into two categories. So, first one, natural slopes, and the second one is artificial slopes. These artificial slopes are also known as built up slopes. So whether it may be natural slope, whether it may be artificial slope, these slopes can be further classified into another two main categories: finite slopes and infinite slopes. So before going to finite slopes and infinite slopes, we will see what is the basically a natural slope and basically artificial slope. So natural slope, the slopes which are formed naturally. Formed naturally by the process of weathering, those slopes are called natural slopes. So example, if we see for natural slopes, hill slopes or mountain slopes. All these are natural slopes. Then coming to artificial slopes or built up slopes. So these are man-made slopes. For a particular purpose, man has built some slopes. Those slopes are called artificial slopes. When we are doing cutting works for canals, for example, we'll be doing a cutting work like this for canal water, for flow of canal water. So these slopes is one kind of artificial slope. Similarly, for embankments, you will be laying up embankment for several purposes like roads, we will be doing embankments. Similarly, for railways, we will be doing embankments. Or for bridges, bridge supports, we will be laying some embankments. So in all these cases, we will be filling up. The natural ground level will be somewhere here. We will be raising up the ground level by filling with some soil in layers. Soil in layers we are going to fill up. So this is the embankment. So now this is also a slope which is an artificial slope. Similarly, here also we will be doing cutting operation for canal purpose, canals, for laying of canals or for passing of canals. So there also we will be having artificial slopes. So similarly, we will be doing embankment work for dams, for storage of water. Storage of water, we will be constructing earthen dams. For earthen dams also similar way, we will be having a slope. So this is the earthen dam, upstream side, and this is the downstream side. So in order to resist or in order to store water at the back of the dam, we will be constructing earthen dams, where we will be having again artificial slopes. So all these are about natural slopes and artificial slopes. Now we will see about finite slopes and infinite slope. So what is this finite slope and what is this infinite slope? So if you see finite slope, a constant slope of finite extent means the length of the slope is limited here. So if the extent of the slope is very less, if the extent of the slope, so if the extent of the slope is very small, then it is called a finite slope. Then coming to infinite slope. It is also a constant slope of infinite extent. Infinite extent. So if the length of the slope is very much large, it is a extent for a longer length, then they are referred as infinite slopes. If we see the example for finite slopes and infinite slope, small embankments for roads, canals, dams, all this comes under finite slopes. Then coming to infinite slopes, hill slopes or valley slopes, all this comes under infinite slopes. Now coming to failure of slope. So what is this failure of slope? So if we see the definition, we can define it as sudden collapse of soil mass. Sudden collapse of soil mass on a slope or at bottom of slope. So we can simply say that failure is nothing but sudden collapse of soil mass on a slope, or on a slope means on the surface of a slope or at the bottom of the slope. So if you see, this is a slope. So if some portion of this slope is failed, some portion of the soil mass has collapsed from this portion. So it is on the slope. On the surface of the slope, if some collapse has taken place, that particular collapse is referred as failure of slope. Or at the bottom of the slope, sometimes at the bottom of the slope also may happen. That can also be referred as failure of slope. Sometimes along completely the slope may happen. Completely the slope may get collapsed. That is also considered as failure of slope. So the sudden collapse of soil mass on a slope surface or at the bottom of the slope is generally referred as failure of slope. So what is the reason behind this failure of slope? If you think, the reason is due to lack of stability. Lack of stability. Is that essential? Stability of a slope is essential? Yes, definitely essential. Why? Because failure of slope is a catastrophic. Means it happens suddenly without any warning. Catastrophic, and which happens suddenly without any warning. So that is the reason analysis of slope stability is very much important to know about the stability condition, and in order to predict the behavior of that particular slope, or in order to predict the failure of that particular slope. So that is why slope stability is very much important. So in order to prevail stability of slopes, we have to know about the causes behind this failure of slopes. So what are the causes or what are the reasons for occurring of slope failure. So if you see the causes, first one is the undercutting. Means if you are doing any excavation at the bottom of the slope, if any excavation or cutting is done, excavation is done at the foot of the hill or at the foot, undercutting or excavation at a foot of the slope. So at the bottom of the slope or at the foot of the slope, if any excavation is done, it leads to gravitational instability. So because of this instability which has occurred because of the self weight, this weight is going to act additionally now, and in order to oppose, soil mass is missing here. That is why instability is going to occur, which leads to collapse of the failure or failure of the slope. That is the first major reason. And the second one is due to increase in pore water pressure. So because of the increase in groundwater table level, if the water table level which was available somewhere here earlier, so if it is rising up, then what happens? Pore water is going to get increased. So when the pore water is increasing, pore water pressure is also going to get increased. So we all know total stress, effective stress is equal to total stress minus pore water pressure. So whenever this pore water pressure is increasing, go on increasing, the effective stress becomes zero. So when the effective stress becomes zero on a soil particle, then all of a sudden the soil mass will undergo collapse due to lack of shear strength. So that is why increase in pore water pressure due to rise of water table, groundwater table. So that is another. And the third one is gradual disintegration of soil structure due to dissipation of pore water. So dissipation means reduction of pore water pressure. So because of the reduction of pore water pressure also, what is going to happen is soil structure is going to get undergo disintegration process, separation process. So because of this, first of all, hair cracks will be developed, and then it leads to fragments, and then all of a sudden collapse of the slope is going to take place. So initially hair cracks are going to get developed in the slope, and later on it leads to fragmentation, separation into blocks, and then all of a sudden the separated elements may get collapsed. So that is because of the gradual disintegration which is going to take place because of the dissipation of pore water pressure. And the fourth one, seepage of water. So because of permeability, if high permeability is provided, then seepage of water may take place through the body of the soil mass, and it may also leads to failure of the slopes. So because of the seepage, so if you see, so if this is the upstream side and this is the downstream side, So water may travel along the body of the slope, and when it is leaving this portion, the soil which was available here also gets eroded. Erosion will be taking place because of the seepage of water through the body of the dam or body of the embankment. So that is why also failure may occur in the slope. Next one, due to shock or impact, because of the earthquakes mainly. If there is a sudden shock or sudden jerk which was exerted because of the earthquakes, then also the soil mass which was available below the slope may undergo some liquefaction. So because of this liquefaction problem also, sudden collapse of slope may occur. That is why this is another reason. So all these are the causes for failure of slopes.